is up, Precal12? We are in our review session. Really part two. Part one was in class, and I believe if you go to On Campus, it's actually at the top of On Campus. It says part one on it. It's a little different than the one that you're currently seeing. But just as a heads up, you could go back in and kind of view that and see some of the problems that we did together. And so that might be something that you might want to check out along with this podcast. I know that I don't have too long. We've got about 25 minutes. So I want to make sure I hop right into some of these questions that I'm anticipating you having. I think the big thing to realize is on 2.7, the 6 problems to focus on, they may be a little different than the actual review, but the same possible types of problems that are there, ones that I would really recommend you look at. One of the ones I want to make sure I start with is this idea of what do I do with the slant asymptote? And so I want to make sure I walk through the process that's here. Many of you are pretty good with pulling out that x and starting this process of factoring minus 15 and then starting from here, and this would be x plus 5, x plus 3, okay? And simplifying that top, we get x minus, or plus 5, x minus 3 over x plus 5 and x plus 3. Now, when we finally simplify, we realize that the x plus 5s cancel, leaving me with the simple version of this, and I'll kind of put it down here just so that you can see it. It's x times x minus 3 all over x plus 3. I think I feel pretty good about that with where we're at here. The next part we identify is what makes the bottom equal to 0 as a vertical asymptote, which would be -3, okay? The horizontal we look at, I look at the original up here. Some of you may look back over here and see that there's a degree of 2 if I were to multiply it. But I like the original just so I don't mess up, to see that the top is greater than the bottom, which tells me that there would actually be none. There would be no horizontal asymptotes. The whole side, we know that when we cancel x plus 5, that helps me get what the x is of the whole, which would be -5. And I could then find what the y is by simply plugging -5 back in for x, both top and bottom. So that would be -5 times -8 when I plug in -5 in for x, all over -5 plus 3, which is -2. And I believe that would be 40 over positive 40 over -2, which would be -20. Okay. So as I go to the x-intercepts, I recognize the top we set equal to 0 for the x-intercepts. So that's x, and then the bottom would be more like the vertical asymptotes. So the top, since I've already got x and x minus 3, I set them both equal to 0 to produce 2, which would be 0, 0, and then 3, 0. And those would be the 2 x-intercepts. For the y-intercept, I go back again to the original, and when I do, I get 0 over 0 times something is 0 over 3, but anything over with 0 on the top, 0 over 3 would just be 0. So that would be 0, 0 as my y-intercept, okay? Now remember with my domain stems from 2 things, the vertical asymptote and the whole. Those 2 things make up my domain. So when I put this down, I could do it 2 ways. I could say that it's from -infinity to -5, -5 to -3, and -3 to infinity. I could do that. Or I could put x is all real numbers, except x cannot be equal to -5 and -3. Cool. Put it either way is fine by me. And that's what we would be looking for with all these parts. Now the slant asymptote stems from the top being 1 degree greater than the bottom. And since that's the case, I could multiply this out over here. I'm sorry, this part out over here, and then divide it by x plus 3. I like to go back to my original. Again, you feel free to do what you want to. In fact, what I'll do, let me go back to this one, mainly because I've already done one that kind of that's similar to the one on the top left. But let me just show you. The top is x squared minus 3x. And I just plus 0 because that would be this multiplied. And I divide by x plus 3. Okay? What times x gets me x squared? Well, that would be x, so we'll put it in there. And then we just distribute x to both parts, giving me x squared plus 3x right there. So we change the signs of both, giving me negative 6x plus 0. What times x equals negative 6x? Well, that would be negative 6 here. And then I multiply it to both parts. So that's negative 6x minus 18. But we know that as we roll here, we get a remainder of 18. We drop the remainder because the x minus 6, which is the slant asymptote, is what we would put there for our slant. So let's put in all of the stuff. We've got a vertical at negative 3. Got it there. No horizontal. X-intercepts at 0, 0, and 3, 0. Got that one. Well, y-intercept, and these are the same, right? 0, 0. Negative 5, negative 20. Since this is so large, though, usually we just have like a hole in it, right, the graph. I would say just drop that as long as you put it in red. If it's off the graph, don't worry about it. And you know the domain. That's not a big deal there. So then the y-intercept, or the slant asymptote, is probably the toughest part because the y-intercept is negative 6. So 1, 2, 3, 4, 5, 6 right here. The rise over run is 1 over 1. Just kind of build that in. So we've got this thing that cuts across here and kind of goes off the graph, which makes it a little tricky. But here's what's cool about this. Since I've already got 2 here, I know that as this goes towards the right, it's going to approach the slant. And as this goes to the left, it's also going to approach the vertical. And then right in between, we just simply combine these two, and that would be sufficient for that part on my right. Remember, we've got 2 zones, one over here to the left of the vertical, and one over here, which is to the right of my vertical. And we plug that in there. For my x and y, let's plug this in. Let's plug in negative 4. If I plugged in negative 4 here, I would get negative 4. That was negative 4 minus 3, which is negative 7, all over negative 1. So that would be 28. Wow, it's 28. So you say, what does that mean? Well, that means negative 1, 28 would be way down here. But it's going to be inside this triangle, so we could just kind of put one here, knowing that there's a point here and showing that there's work here for my T-chart, then in fact it's in there. Now, if I come to a test, I might do another one, another point. That way I know that I know. That might be something that might be helpful as we move forward through this, okay? Cool. Let's go to another one. I thought this one was a good one right here. So number 2 and number 1 are ones that you might want to just kind of look for. Number 1 we did in class, and I think it's on the other podcast. The big key is knowing that if I have 3 of these values, that means I'm going to have 3 different solutions where you've got x, x plus 2, and x plus 4i. But by rule, if I have negative 4i, I must also have the reciprocal, which was 4i, or x minus 4i. So if I was getting this in the standard form, I would make sure that I would first find what the product is of these first 2, what is the product of the last 2, and then simply multiply those together at the end. So again, you could go on and check it out, but you get x squared plus 2x is here. These would be x squared minus 4ix plus 4ix plus 16. You can go back if you need to check that out more detail, which would be x squared plus 16. And then you would just distribute sorry, this is x squared plus 2x. And then you would just distribute x squared plus 2x to x squared plus 16 to get my final answer. All right, excellent. All right, here we go. Next one. Find all the zeros. Really, you could put in solutions there for this for the actual polynomial. Now, since it's to the 4th, we recognize that there's going to be 4 different solutions. Now, all 4 may not be actual x-intercepts, And that's possible to have. So just kind of remind yourselves of that when you're solving for it. One thing you could do is do P over Q, but a lot of times that takes a long time. So what we want to do is plug this into my calculator. And when I do, I can either go to the second graph, which is your table. If you look at the table and see where is y0, you could also go to the graph itself and see where is it across the x-axis. Where are the zeros that are there? And so those are all options that we could have from this. This might be good just to kind of go through here. Let's see if we can pull this up. In fact, I think I've got it here. Yeah, here we are. Okay, let's see if I can. I'm going to actually not do this, change that a little bit. What's up, peeps? Throw this up there. Hope y'all have a good winter break, by the way. Almost there. Almost there. Okay. So here I am on the graph. I could go ahead and graph this. In fact, let's go to Zoom Standard. And we may just see one different value. There it is. It goes through 2. If you notice that, it goes through 1 and then 2, which will help. Another thing I could do is, let me see if I could zoom out. If I zoom out, let's see what else I get here. I'm going to get one at 2 here. Okay, I get one over on this left side. I could actually count these over and see where it is, or I could go to second trace. Another way I could do this is go to second graph and go to that table. And we know that maybe you have to go up and down for this. Like I could scroll up and down to try to find it. But we know that negative 11 is 1 because it has a y that's 0 as well. Okay. So the two real solutions that I have, and that's really all I need to find, because once I get something to where it's x squared, it makes it a lot easier to solve for. So we would say 1 is negative 2 and 1's 11. So we're going to plug negative 2 in. We're just going to run through synthetic. And when I do this, since I know it's an x-intercept, I should get something that would be, actually, I think it's positive too, because as I'm doing this, this is actually incorrect here. Let's see if we can backtrack. And if you mess up and get a remainder of 0 of something that's other than 0, that just means you messed up somewhere. Or maybe you put in the wrong sign. It should be positive too. 12, that's 24, 14. 28, 33, 66, that produces 0, okay? On the simplified part, I go to negative 11 now. So bring down the 1. And you'll see again, we get something that looks like this and produces a 0. Now, it could be that the other two are actual solutions that are x-intercepts, but it could be that they're not. So first thing I do is we have 3 ways of doing this. Can we solve it? Well, it's hard to solve it just the regular way because you got an x and an x squared. So that's tough. So I'm going to say no to that. Can I factor? Well, 2 numbers that multiply to equal 3 but had to be equal to 1, I don't see that there. Another way you could do it is the quadratic. And that's where I'm going to kind of land on. So with the quadratic, this would be x is equal to b, or negative 1, plus or minus the square root, b squared is 1, minus 4a times c is 3, and then all over 2 times a, which is 2. Okay? So this is negative 1 plus or minus 1 minus 12 is negative 11, or square root of negative 11, all over 2. Okay? So really the answer to this, and this actually is both of these, right? Because you have both the positive and negative 1. You would say negative 1/2 plus or minus I square root of 11 all over 2. And I can't simplify, I'm sorry, that whole thing. So all of this, one's plus, and then the other's minus, and there's our 4. The key, get to the quadratic form, and that will help you as you move beyond that. Okay. This is a good one, too. If you look at number 8, just remember that you have to have its conjugate as you're doing that there. That's something to just be careful of. Number 9, and I know I'm going everywhere here. Hopefully this is helpful for you. I would make sure that in order before I go after any asymptotes. So really we have 3, right? We have vertical asymptote, slant asymptote, and then the horizontal asymptote. And then the last is what is the domain. So on the top side, we have negative x squared minus 2x plus 12 all over 2 times 4 plus x. Now, it might be helpful to just try to factor this top side by pulling out a negative first, making it x squared plus 2x, make sure the signs change, minus 12. So really this is x. Can I factor that? I don't think I can. So actually I can't factor it. So this actually is as simple as it's going to come. So the vertical asymptote, when I set it equal to 0, is -4. The degree of the top is greater than the bottom, so my horizontal would be none. And therefore, my domain would be x is all reals, except x cannot be equal to, that's what I meant to do there, not equal to, -4. Cool. The slant asymptote, all right, so it's 1 degree top than the bottom, even if I multiply this, because you would get 8 plus 2x or 2x plus 8. So we do have a slant asymptote. This is just a good practice again. So this is going to be divided into the top. So it would be 2x plus 8 goes into, we redo it to where it's highest to then lowest. Okay, so what times 2x gets me negative x squared? Good question. 1/2, right? Negative 1/2. X times 2x, it should produce the same thing. So that would be -1 x squared, negative x squared. Negative 1/2 x times 8 is -4x. And then I change the sign, giving me 2x, bring down the 12. Now the only thing I need, because I'm not concerned with the remainder, is what times 2x gets me 2x. And that would just be 1, right? So 1. The next thing is the remainder once I get the whole number. So my slant asymptote is y equals -1/2 x plus 1. That's a tougher one there. Tougher one. So again, just the asymptotes and the domain is what it's looking for. But remember, there's 3 possibilities. The slant only comes when it's 1 degree greater on the top than the bottom. A good practice one right here is number 11, kind of similar to number 2. Might be a good one there. Number 13 is a good one too to practice on as well as you're going through that. I want to do one more of these. How much time do I have? I've got 5 minutes. This is perfect. It'll actually be awesome to go through one more of these. All right, let's go through the bottom one, 3x minus 15. Actually, I already done that one, I think. Yeah, I like this one. Let's do this one. Okay. First thing, let's factor. Okay, so I'm going to go kind of quick through this. X times x plus 3. On the bottom, I get, when I pull out an x, I'm left with x squared minus 3x minus 18, which is x minus 6x plus 3. Cancel top and bottom to get me 1 over x minus 6. But because 2 things are canceled here, I'm going to get 2 wholes, which is a little strange. Okay, so one will be 0, and the other one's -3. And what I could do is plug 0 and -3 in for x to see what I get out for y. So plug in 0 for x, I get -1/6. Plug in 3 for x, I get -1/3. Okay, so I've got my hole. And let's plug it in. Let's just do it. So -1/6 is here, and -3. Oh, it should be -1/9. My fault. Like, wow, that didn't make sense. -3, -1/9. Okay, so we've got those. Vertical asymptotes stem from the new one, right? So that would be x is equal to 6. So we'll put that there, 3 or 4, 5, 6. Some of you may want to graph it as you go. It's up to you. Since the degree on the bottom, you could go to the original or the new one. But bottom's greater than the top, so this would be y equals 0. I almost said none. That's the opposite when it's greater on the top than the bottom. So you've got a horizontal here. X-intercepts plug the top, set it equal to 0. So 1 equals 0, well, that doesn't exist, so we would just say none. and y-intercept, plug the 0 in for x to get -1/6. That would be the y-intercept, which is the same thing as this hole. Notice that these two are the same. But because it's a hole, we're going to just go with the hole, although it touches at the y, doesn't really because of the hole that's there. There is no slant because remember the top has to be 1 degree higher than the bottom. I forgot one person in my class said, well, coach, that means that you can't have both the slant and a horizontal, which is absolutely true. Absolutely. So our domain would be, I'll do it this way. X is all reals, although you could do it the other way. X cannot be equal to two things, vertical asymptotes and holes. So you would say 0, -3, and 6. Probably should put them in order, but I won't count on for that. Probably should, but it's good. So as we go to the point side of things, what's cool about this is we've already got 2 here. So we've got 2 zones, zone 1 and zone 2. And if I had 3 zones, I would put the third one in there, but I've only got 2. So I could go this way into this way with 2 different holes that are there, approaching the vertical and the horizontal. Now on my T-chart, I don't have any values to the right of 6. So we're going to plug in like 7 and 8. So plug in 7, 1 over 7 minus 6, 1 over 1 is 1. Plug in 8, that would be 1/2. So that would be 7 and 1 and 8 and 1/2. So this would go this way and upward. Okay? And that would be the answer. That's what we're looking for when we are graphing rational expressions that are here. Hey, I hope this helped you. I hope this was of help to you. I've got like the bell's about ready to ring, and we'll go from there. If you need some more help, check out the podcast we've been doing. Also, if you go to the one above this on campus, you could go ahead and check that out as well. This is part 2, and yeah, I hope that was helpful. I hope you all have a great day, and I love you all a lot. I feel pretty confident about this. So tear it up. I will be here Friday morning. I will be here tomorrow morning because I missed today. So come in tomorrow morning on Friday morning and come out, check it out. I will have to leave like around 8:10, so just so you're aware. So come around 7:30. Let's check out some questions. If you have any, we'll go from there. Be blessed. Have a great day. We'll see y'all. Bye.